Hi, this is Julie Hester, and in this video I'm going to show you how to use floating point numbers in C++ programming. The C++ language has two types of numbers. The first type is integer, and integers are your basic counting or whole numbers. They can be negative or positive, and they look like the numbers here below. -2, -1, 0, 1, 2, and so forth and so on. When you first learn how to write programs in C++, you often use integers, and so you might have created a variable that looks like this. Here I'm defining a variable named count, and its data type is int, and I've initialized it to the value of 5. What I want to focus on here, however, are floating point numbers. And these numbers are fractional numbers that use a decimal point, and they look something like this. Here I defined a variable named temp with a data type of float, and I've initialized it to 98.7. Now the thing about the float data type is this is an older data type, and similar to how computers have moved from 32-bit to 64-bit operating systems and processors, float has been replaced mostly by type double. And so in modern programs, I'm going to use a double instead of a float. So here I'm defining the same variable temp, but this time it's using a data type of double. So when you're writing a program, you have to decide which data type to use for each variable. And here's how you can think about it. We want to use an int or an integer for things that we can count, things that we aren't going to have partial numbers of. So one example would be if I want to know how many drinks I want to buy. I'm not going to buy half a drink, so an integer is a great choice for this variable. So here I've created a variable num drinks. Its data type is int, and I've initialized it with 3. I'm going to use a double when I'm working with things that have fractions. And that could be things like money, percentages, measurements, things like that. So when I'm working with the drinks that I'm buying, those drinks are going to have a price. Price is a unit of money and has fractional values for dollars and cents. So I'm going to create a price variable with data type double. And here I've created price and initialized it with 1.59 to represent $1.59. So looking at these two variables, I have an int and I have a double, but I may want to use both of them in a calculation. So I'm going to create a calculation where I'm using both data types, and that's going to be perfectly fine. I might ask a question like, how much do 3 drinks cost? So I have my integer holding the number of drinks that I have. I have my double that has the value of the price for each drink. And then I need a third variable for the total, so that I know if I were to buy 3 drinks, how much would I have to pay for all 3 drinks together? Now for this third variable, I need to decide if I want to make it an int or a double. And the total is also going to be a monetary value, and so I'm going to also make total a double. And I can just add that second variable onto the same line as price by putting a comma between the two variable names. So now that I have my 3 variables, I can calculate how much it would cost to purchase 3 drinks at $1.59 each with just a simple mathematical expression. So in this expression, we have an integer multiplied by a double, and we're saving the value as a double. So let's see how we can put this in a program. So now I've opened Visual Studio, and I'm going to create a program about buying drinks in C++ and Visual Studio. I've already opened up an empty program, and it's ready to go. So the first thing I'm going to put in my program is a short comment at the top, just describing what this program is about. And this program is a floating point demo for buying drinks. I'm also going to put another comment up here, just with my name in here. And I think that will be fine for now. Well, this program is going to interact with the console line, the console window, so I need to include a header file to allow this program to interact with the console window. So like all other programs I'm demonstrating here, I'm going to put in hashtag or # followed by include. And then I'm going to put inside angle brackets the name of the header file that I want to include. I need to include iostream. And as soon as I see enough of the word that I'm looking for here, I see iostream popped up in this little box, I can just hit a tab and I don't even have to type the whole name. Well, that's part of the Visual Studio IDE. If you're using a different IDE, you may have similar behavior to that, or it may work a little bit differently. Now in my programs, for simplicity, I will use the namespace standard so that I don't have to put standard in front of a lot of my functions. Some people prefer not to do that. So when you look at other examples on the internet, you may see people who don't put using namespace standard, and their programs may look a little bit different, but they'll work just the same. All right, so lines 4 and 5 are setting up my environment. And now I need to create a main function. This is the function that will be invoked when this program executes. All programs must have a main. And a main is going to have a return type of an integer. So we're going to put int followed by the name main and empty parentheses. After that, I'm going to put an opening curly brace. Visual Studio is helping me out by adding the closing curly brace. And now I can just press enter to add lines in between. The main function has to return a number to the system. That number is used to indicate if the program executed successfully. So I'm going to return a 0 here as the very last line of code in this program. So that when this program runs, it's going to return a 0 to the operating system. And these things here that I have on the screen are the basic things that I'm going to include in any program that I write. The actual meat of the program, or what we're creating, is going to go between lines 7 and 10 here. And that's what I'm going to write now. So the first thing I want to do is declare my variables. I'll just put a little comment here to indicate that this section is about declaring variables. And sometimes when I do programming demos, I'll put in more comments than I might put in a commercial program just so that if you're looking at the program later, it'll help you remember what's going on where. And I like to put my variables up at the top so that I know where all of them are. And if I have any issues with variable names not matching or things like that, I know where to find my variables. All right, so this program is about buying drinks. And this could be a situation where I'm going out with some friends and we're going to buy some drinks at, say, a fast food restaurant. So the first thing I need to know is how many drinks am I buying? So I'm going to put a variable in here for the number of drinks. We are counting the number of drinks, so that will be an integer. And then I will just put the name num drinks, and I'm going to initialize that to 3. Also, we need to know the price of each drink. The price is a fractional number, so it's going to be a double data type. I'm going to name this price and initialize this one to $1.59. Now, when I'm working with money, I know that $1.59 is money and that it's $1.59. But when I assign a value in C++, I can't add the $ formatting. I just need to put the numbers like I have here. And then the last variable that I need is I need cost to hold the cost of all 3 drinks. So like we had said before, I'm just going to add this to the end of this line 11 by adding a comma and then the other variable name total. Now that I have those numbers and those variables, I can calculate the cost. So I'm going to add another comment here. And I'm just breaking up my program into sections. I can't do anything and calculate cost until my variables have been declared. So I have all the variables declared above this section. And what I want to calculate is how much do 3 drinks cost? So I'm going to say total equals num drinks. And there again, as I started to type the variable, I can see the name down here in this little box. And if I hit tab or enter, it's going to use that name for me. So I'll do enter this time. Oh, sorry, not enter, just tab. Num drinks. And I'm going to multiply it by price using the tab key, not the enter key. All right, so that's my calculation for total. And now that I have that in my program, I'm going to display the output. I want to show how much those drinks are going to cost. So I'm going to use cout to send a message to the console window. I'll say cout. And I'm going to say total, colon. And I'll add a $sign just to make it look nice. So there's my string literal. I'll add another insertion operator and put my variable. I'm going to use variable total. And then one more insertion operator. And I'm going to put a line break or end L. So now that that program is written, I want to test it. I'm going to go up to the top of Visual Studio here, and where it says debug, I'm going to click that menu option. And I could do this a couple of different ways. I could go into debugging with F5. And that's something that's good to do when I'm wanting to really look at the inside and the internals of how the program's running. But for today, I don't want to do that. I just want the program to run. So I'm going to choose Start without debugging. And once I click that, Visual Studio is going to attempt to compile my program. An output window has opened up here at the bottom of the screen. And if I had any errors, I would see them down there too. But this program did succeed to build. It was successfully compiled and then it executed. And so I'll move the window over that shows the output here. And that output says $4.77. Now, whenever you're writing a program, you want to make sure that the calculations are working correctly. And so I'm going to double check by opening up my calculator. And I want to make sure that my program is calculating this value correctly. So I'm just going to enter in my calculator here 3 times 159. And sure enough, the answer is 477. So it looks like this program's working correctly. I'll go ahead and close that out and close the menu there. Now that's a simple calculation of how much 3 drinks might cost, but as you know, when you purchase most items, you usually have to pay sales tax. So let's add a sales tax calculation to this. Now, if you know how to work with named constants, then a named constant would be appropriate here. But I'm going to hold off on named constants for now, and I'm just going to make my sales tax rate an additional variable. So under my last double, I'm going to add one more double. And this is going to be the percentage of the tax rate. I'm going to call this variable tax rate. And the tax rate I'm going to use is 8.25%. But the way we have to write it is we have to express the percentage as a decimal. And when you convert percentages to decimal, in effect, you're dividing the number by 100, or you could say that you're moving the decimal place 2 places to the left. So I'm going to write 8.25% as 0.0825. Now, not only do I want to have a variable for the tax rate, I also want to have a variable that's going to hold the amount of sales tax that I'm paying. So actually, I'm going to add one more thing to this line. Before the semicolon, I'm going to put in a comma here, and I'm going to add the variable sales tax. Okay, so now we have 2 new variables. I have one for the tax rate, and I have one for the sales tax. So now I need to change how I'm calculating the cost and add some more calculations. I'm going to come over here to my calculate cost section, and I think I'm going to go ahead and close this output window. Whenever one of these windows is in your way, you can just close it, and later on it might get reopened if Visual Studio needs it, but I'm going to get that out of my way. And I'm going to come over here to the calculate cost section, and I want to add a calculation for the sales tax. I'm just going to add a line after line 14. And I'm going to say sales tax. Now, how do I calculate sales tax? Sales tax is basically going to be the number of drinks times the price times the tax rate. And there's a couple of different ways I could approach this, but this is the way I'm going to put it in this program. So I'm going to put in here number of drinks times price times tax rate. And that's going to tell me how much sales tax I have to pay on the 3 drinks. Now when I calculate the total, I want to not only have number of drinks times price, but I also want to add the sales tax to that total. So I'm going to put a plus here and sales tax. All right, so now I have modified the calculation for the total. It has 3 variables involved: num drinks times price plus sales tax. And when I see that I am mixing multiplication and addition, I need to remember there's an order of operations here. And when these numbers are calculated, we're not necessarily going to go from left to right. Instead, we're going to go by the order of operations or the precedence, and it's a lot like math. We're going to choose multiplication before addition. So in this situation, the way it's written is exactly the way it's going to be calculated. But if I want to be really sure that it's doing it the way I want to do it, and I don't want it to look confusing, I can add parentheses just for clarity. And I'm going to do that. I'm going to put parentheses around the multiplication. That tells me that the multiplication is going to happen before we add the sales tax to the product of that multiplication. Okay, so now we know how much sales tax we're going to pay, and we know the overall total for buying the 3 drinks. Let's come back down to display output now and add a line after line 18. I also want to display the sales tax. So I'm going to say Cout, and I'm going to say tax with the $sign. And just like I'm doing on the total line, I'm going to add another insertion operator followed by my variable sales tax, a third insertion operator, and a line break or end L. So now this program looks complete. Let's go ahead and test it. And sometimes you will see something up here that looks a little bit strange. It looks like Visual Studio is flagging a couple of things up here at the top of the program. And sometimes when you see that, it's left over from some other problem. Now that I scrolled up there, it looks like it's flushed it back out. And so usually, if it's a leftover error, it will take care of it and it will remove that error indication, like it did just there. All right, let's go ahead and compile and run this program. I'm going to go back to debug, start without debugging. And now what I'm going to see is that the taxes due on this purchase is $0.393525, and the overall cost is going to be $5.16353. And just thinking back to how we'd calculated this before, without tax the total had been $4.77. If I were to add about 40 more cents to that, $5.16 looks like a reasonable answer, and so it looks like the calculations are correct. However, if you work with money, you know that we don't take money out to 5 or 6 decimal places when we do calculations, and so we're going to want to do some things to fix the way these numbers appear. And that's what I'm going to show you in the next video about how to format the output.